Hi, this is Teacher Jubes, and in this video, we're going to talk about algebra. Algebra is just another branch of mathematics that formalizes the laws of arithmetic. So whatever you do in arithmetic, we're going to apply those things in algebra. But in this case, we're going to deal with not only with numbers, but also with symbols. So let's start with algebraic expression. I want to emphasize or discuss this concept through examples. Let's have example number 1. Ben has 3 apples. If he gets one more apple, how many apples does he have now? At the beginning, he had 3 apples. And if he gets one more apple, how many apples does Ben have now? So this is what you're going to do. We have here 3. This is the number of apples Ben had at first, and he gets one more. So he has now 4 apples. Very simple, right? Let's have letter B. If he gets 4 more apples, how many apples does he have now? So same or similar to what we did in letter A. At the beginning, Ben had 3 apples and he gets 4 more apples this time. So he has now how many apples? 7 apples. It's just like that. Now, what if we have letter C? If his friend gives him some apples, how many apples does he have now? So in this item, we don't know yet the number of apples given to Ben. It says here some. So this word might entail 2 apples, 4 apples, even 10 apples. We don't know yet the number of apples. So what we are going to do is we can represent this with something else using a symbol. Let's say this is N. So we can read this problem as if his friend gives him N apples, how many apples does he have now? So just like what we did in letter A and in letter B, at the beginning, Ben had 3 apples and his friend gives him how many apples? N apples. So we have here plus N. So this is the number of apples Ben has now. Did you get this? We can also solve letter C using bar model. So we have something like this. This is 3. And then his friend gives him some apples. So we have something like this. We don't know how long this bar is. So this is letter N. We use letter N because we don't know the number of apples given to him by his friend. And if we're going to find this total, this whole, we're just going to combine the parts together. So we have here 3 plus N. So this is now 3 plus N. So this is the number of apples Ben has now. Okay? And I just would like to emphasize that 3 plus N is just similar to N plus 3. Remember, in addition, we don't care about how the addends are being ordered. Okay? So 2 plus 3 is the same as 3 plus 2, something like that. So 3 plus N is an example of an algebraic expression. So what do you mean by algebraic expression? It's just something like 3 plus N. It can also be 4. 4 is also considered as algebraic expression. 7 is also considered as algebraic expression. And we also have 3 plus N. This is also an algebraic expression. And the N here is what we call variable. When we say variable, it's from the word vary. Vary, it means its value changes from time to time. It depends on what value a person is assigning to this variable. Okay, so if I'm going to talk about variable, I'm talking about the symbols, the letters in the English alphabet, even the letters in Greek. So those are examples of variables. Okay, the opposite of variable is constant, just like 4, 7, 10. Those numbers are constants because when we say constant, its value will never change no matter what happens. Let's have example number 2. Alden has 20 cookies. Tom has 5 cookies. How many more cookies does Alden have than Tom? So it's obvious in the problem that Alden has more cookies than Tom, right? So if you want to know how many more cookies does Alden have than Tom, then we have to use subtraction. What numbers do we subtract? We're going to subtract 20 and 5. Then we get the difference, which is 15. 15, okay, what do you mean by 15? It means that Alden has 15 more cookies than Tom. Did you get that? Next item. Tom has Y cookies. Here we go again. There's a variable Y, so we don't know its value yet. Okay, its value varies. Its value changes. It depends on what number you assign to that variable Y. The question here is how many more cookies does Alden have than Tom? How many more cookies does Alden have than Tom? So for letter B, we can solve this using bar model, or we can just solve this just like what we did in letter A. So let's just solve this item using bar model so that you will get accustomed to the use of bar models in solving word problems. So we have here 2 people involved in the problem. The first person is Tom, and he has how many cookies? Y cookies, so we have to draw a bar to represent the number of cookies Tom has, and this is Y. Okay, and Alden has how many cookies? Alden has 20 cookies. The question is, who has more cookies? So if you're going to read the problem, the question of the problem, how many more cookies does Alden have? The question is implying that Alden has more cookies than Tom, which means that if we are going to draw a bar model for Alden, it should be longer than that of Tom's. So we have from here, this should be longer because Alden has more. Okay? And how many cookies does Alden have? There are 20. It's given in the problem. So what we are looking for here is the difference. The difference between the number of cookies Alden has and the number of cookies Tom has. Kasi the question is how many more. So if we're looking for the difference, we're looking for this portion here. This is the difference. This is question mark. Did you get that? This is the difference. So up to this point, both of them, Tom and Alden, have the same number of cookies. So this is the excess, kumbaga. This is the excess. So this is what we want to look for. Okay, so based on this model, by the way, the model is called comparison model because we're comparing 2 quantities. So based on this model, to find this difference, we have to use subtraction. And what numbers do we subtract? We have 20 minus y. And 20 minus y is already in the simplest form. We can no longer simplify this. This is another example of algebraic expression. If we know the value of y here, then we will know the value of the difference of their cookies. Okay? Now, I have a question. Is 20 minus y, I'm going to write it down here, is 20 minus y the same as y minus 20? What do you think? Do these two expressions give you the same result? If your answer is yes, then there's still something that you have to learn more about subtraction. One property about subtraction is that terms can never be interchanged. 8 minus 5 is not the same as 5 minus 8, right? You will never interchange the numbers in subtraction, unlike in addition and multiplication. So in this case, 20 minus y is not the same as y minus 20. Don't ever interchange the terms. Okay? So this is our final answer, 20 minus y. Next, number 3, Andrew has 2 empty boxes. Andrew has 2 empty boxes. He puts 12 books into each box. How many books are there altogether? There are 2 empty boxes and each box has 12 books. Okay? Each box has 12 books. So our operation here is multiplication. You can also use addition. It's up to you. Remember, repeated addition is multiplication. So we have here how many empty boxes? How many boxes? There are 2. And Andrew puts 12 books into each box. So you have to multiply this one by 12, and this will give you 24. So there are 24 books now altogether. Okay? And the other way to get this answer is you can just add 12 and 12. 12 plus 12 is also 24. And 12 plus 12 is also the same as 2 times 12. Letter B, he puts n books in each box. So you encounter another variable again. This is a variable. So any letter that you encounter in math, it's called variable. Why variable? Because its value varies. Its value changes. How many books are there altogether? Okay, I want to solve this using bar models. So there should be 2 empty boxes. So I'm going to use this box. There are 2 empty boxes. And then he puts n books in each box. So one box has n books. How many equal boxes do we have here? There are 2 equal boxes. So I can have here 2 times n. Okay, remember in our previous video, if you have something like this, you count the number of groups or units. This is considered as one unit, another unit. But I just want to use box or square in order for you to understand what I'm saying here. Okay, so there are 2 units or 2 boxes. So that's why I have here 2. And then times n, because one box has n books. And 2 times n is the same as 2n. In algebra, we don't use x for multiplication. If you're multiplying a number and a variable, you just put them side by side, just like 2n, but not n2. Okay? The number should always come first. 2n, not n2. So 2n is the same as 2 times n. Okay? So there are 2n books now. Next, Number 4, and this is the last example under algebraic expression. Number 4, letter A, 16 grams of raisins were shared equally between 2 children. How many grams of raisins did each child receive? So there's a word here, shared or share. Remember, share implies what? When you do sharing, when you share your blessings to other people, what do you actually do? You're actually dividing whatever you have to uh, to your friends. Yeah, to your friends. So it's about dividing. So share or grouping, that implies division. So in this problem, we are going to use division to answer the question. Okay, so we have 16 grams, and 16 grams is divided into 2 because there are 2 children. So what our equation here is 16 divided by 2, and 16 divided by 2 is 8. How many grams of raisins did each child receive? Each child received 8 grams of raisins. So one child 8 grams, another child 8 grams. We have a total of 16 grams. Did you get that? Letter B. Here we go again. There's another variable. It's variable D. There were D grams of raisins in a box. The raisins were shared equally between 2 children. How many grams of raisins did each child receive? So at the beginning, we have D grams of raisins. So this whole bar is D grams. And this whole bar is divided into 2 equal parts because there are 2 children. We have to divide D grams of raisins into 2. Okay, so we have to divide this one into 2 equal parts, and we want to know 1 part. Okay, so we're looking for 1 part. I think I mentioned about missing part in my previous video. If a part is missing, you either subtract or divide, right? In this case, it's division. So we are going to divide D by how many number of units do we have here? 1, 2. Divide D by 2. And this is already our final answer. And D divided by 2 is the same as D over 2. Okay? Sir, can we have 2 divided by D? No, because subtraction and division, the order of the terms is important. You cannot interchange them. Okay, that's all about algebraic expression. Now let's move on to, oh, we're not done yet. There's still letter C. So let's answer letter C first. Mrs. Reyes baked white tarts at first. White tarts at first. She ate 4 tarts. Oh, so I'm going to draw a bar model here. Should be long. Why is it long? Gusto ko lang long. So this is Y. This is Y. She ate 4 tarts. It means we have to remove 4 from this bar. How long is 4? Just estimate. It's up to you. So this can be 4 units. So this should be removed. Okay? So this is 4. The remaining, this is the remaining. The remaining tarts were shared equally among her 3 children. So the remaining portion should be divided into 3 equal parts. So we have here one part, another part. So these parts are equal. Okay? How many tarts did each child receive? How many tarts did each child receive? So we want to know one unit here. We want to know the value of one unit because this is child 1, child 2, and child 3. So what is going to be our expression here? So we have here y. She ate 4, so 4 tarts minus 4. And you divide the remaining by how many children? 3. Did you get this? No? This is already our final answer. Or we have here y minus 4. Y minus 4. Okay? This is y minus 4 up to here. This is y minus 4 because you take away 4 here. You take away 4 from this whole thing. So the remaining is y minus 4, and there are 3 equal parts. That's why we have to divide y minus 4 by 3. And this is the same as y minus 4 over 3. Okay? So all you have to do here is just understand the problem. Okay? If you cannot understand the problem in just one reading, then you have to read the problem again. And if possible, always use models. Always use models to solve the problems. Okay? Why? Why do we have to always use models? So that in the future, it would be very easy for you and convenient for you to use models in solving word problems because that's what we will be doing in the future. Okay? Now, let's have evaluating algebraic expressions. Evaluation, if we're going to check your dictionary, evaluation is about making judgment. Yeah, that's also true in mathematics. We are also going to make judgment. But how? The question is how? So evaluation in mathematics is you're just going to simply assign value to the given variable or to the variable involved in a certain algebraic expression. And then you simplify the resulting expression by applying MDAS rule, and that's it. That's the value. That's evaluation in mathematics. For example, I have here 3. What's the value of 3? It's 3, right? Because 3 is constant. Its value is always 3. No, even if there's a strong typhoon, its value is still 3. Even if there's COVID, its value is still 3. It will never change. But if I have here 3 plus y, 3 plus y, 3 plus y, the value of this expression depends on what number you assign to y. For example, if y is 2, then we will replace y here with 2, so we get 3 plus, what's the value of y again? It's 2, and 3 plus 2 is 5. This is the value of the given expression when y is 5. And the process of doing this is called evaluation. Okay? Another example, if y is 10, then what is going to be the value of this expression? We have 3 plus, what's the value of y given? It's 10 this time. So we have here 13. The value of this expression when y is 10 is 13. That's why y is called a variable, because its value changes from time to time. It depends on the person. So let's have some examples here. Number one, find the value of x plus 5. Right now, it's hard for us to find its value because there's no given value for x. When x is 9, we have here 9 plus 5, we get 14. The value of x plus 5 when x is 9 is 14. That's evaluation. When x is 15, so we have now 15 plus 5 equals 20. This is the value of x, and plus 5, that is 20. So the value of x plus 5 when x is 15 is 20. Let's have number 2. Find the value of this expression m over 4 minus 9 when m is 36. So the first thing that you're going to do is substitute or replace m with its given value. And the given value of m is 36. So we have 36 over 4 minus 9. Your next problem would be, how do we simplify this? Always remember, always keep in mind the m-dash rule. So 36 over 4 is the same as 36 divided by 4, which means we have to perform division first. Okay? 36 over 4 will give you 9, and you still have your minus 9. 9 minus 9 is 0. Number 3, find the value of 8. This is read as 8 times q minus 3. Again, this is read as 8 times q minus 3. So your goal here is to find the value of that expression given q equals 9. So we have here 8 times, replace q with 9, and then simplify. Okay? That's why we started our lesson with review on operations, because that skill in math is very, very, very important. So 9 minus 3 here is 6. We have to simplify first the terms inside a grouping symbol. Okay? So this is equal to 8 times 6. And 8 times 6 is 48. Final answer. What is 48? 48 is the value of 8 times q minus 3 when q is equal to 9. Okay? So that's all about evaluation. This time, our goal is how we are going to simplify algebraic expressions. How we are going to simplify expressions involving variables, symbols, letters. Okay? So this is what you're going to do. Let's have number 1. A rod of length A meters is joined with another rod also A meters long. What is the total length of the two rods? So we have here one rod. Its length is A. Right? It's given A. And we have another rod. Its length is also A. What is the total length? So we're looking for the whole thing here. So basically, we're just looking for the sum of A and A. And what is A plus A? 1 apple plus 1 apple equals 2 apples, right? So A plus another A is just equal to 2A. Did you get that? That's simplifying algebraic expression. Number 2, and Ben and Claire have B pesos each. Okay, each one of them has B pesos. Find the total amount of money they have. So there are 3 people involved in the problem. So there should be 3 boxes here. boxes of equal size. Why? Because they have the same amount of money. So one box is B. Anne has B pesos. Ben has also B. Claire has also B. So we're looking for the total here. Okay, so there are two ways of doing this. You can add B plus B. You can have here B plus B plus B. Why are there three B's? Because we have here three B's. Okay, and B plus B plus B, this is a repeated addition. It's the same as 3 times B. Where is 3 coming from? There are 3 equal boxes and one box has 3. I'm sorry, one box has B. Okay, and 3 times B is the same as 3B. This is already the simplest form. Okay. Next, we're almost done here. Number 3, letter A, 2A plus 3A. 2 apples plus 3 apples. How many apples do you have now? There are 5. Okay. Letter B, 4M minus 3M. So 4 mangoes minus 3 mangoes. How many mangoes left? There's one mango left, right? So I just would like to emphasize this, that 1M is the same as M. You don't have to put the 1 beside M because it's already understood that there's a 1 here. Okay? 1M is the same as M. If there are 2 M's, then you have to put 2. As simple as that. So we have here 1M, and then you bring down minus M. You have now 1 mango minus 1 mango equals, what do you have left? 0. You have nothing left. Did you get that? Giovanni minus Giovanni is 0. When you subtract a number to itself, the answer is always 0. Okay. Letter C, we have here 4x plus 6 minus 3x. So in this case, 4x and 6 cannot be combined into a single expression. Why? Why? It's just very simple. You cannot combine them. Okay? You cannot combine apples and bananas unless you're going to make smoothies or shake. Okay? Another example, I have here 2 apples plus 3 bananas. Okay, this is equal to 5 apple banana or 5 banapple, something like that. No, it's not like that. You can never combine 2 apples and 3 bananas into a single expression because these two are different terms. Different terms. They're not of the same kind. Okay? They're not of the same kind. 4x is one kind, 6 is another kind. Ano ba yung 4x? 4x is a variable. 6 is a constant. I mean, 4x is, yeah, it's a variable. Consider it as a variable. 6 is a constant, another kind. You cannot combine them. So what we can do here, we can only combine 4x, and here, minus 3x. We can combine these two terms because they are of the same kind. Okay? The same kind. So 4x minus 3x plus 6. Okay, what I'm doing here is I'm just rearranging the terms. I'm just rearranging the terms. This is addition or subtraction. It doesn't matter. Okay? 4x minus 3x plus 6. 4x minus 3x is x, right? You have 4 x's, you take away 3 of them. How many x's do you have left? 1x, right? And 1x is the same as x. And you copy plus 6. Again, x and 6 are of different kinds, so this is already the final answer. So that's it, grade 6, that's all about algebra. So in this video, we have tackled about algebraic expression, how to evaluate algebraic expressions, and how to simplify algebraic expressions. Okay, so see you in my next videos.